6.5 worksheet, operations with radical expressions. So let's work through this. So it's a lot like the last worksheet, except for now it's not going to be all nice. Like that's the general difference. So like here, radical 72. I don't know what the square root of 72 is. I'm going to break it down. So it's 2 times 36. I always start small if you notice me. But I do know what square root of 36 is. Remember, that's all I need. Square root. So square root of 36 is 6. So there's a 6 on the outside. That poor 2 has to stay inside. Now with the variables, we're going to do the same thing we did last time. Right? This root here is a 2, and we don't see it. So we just divide the power by 2. There's one big difference though. So 8 works out as 4. That goes on the outside. Right here at the b. It doesn't divide evenly. You get b 2 remainder 1. Right? 5 divided by 2 is 2 remainder 1. So how does that work? Well, this part goes on the outside, b squared. And the remainder stays on the inside. So there's a b to the first on the inside. And there you go. So the next one, square root of 9. Hey, I actually know that. It's 3. Then let's look at the variables. 15 divided by 2, because remember there's no number here, so it's a 2. That is 7 remainder 1. So there's going to be 7 a's on the outside, but 1 on the inside. B3 divided by 2 is 1 remainder 1. So there's 1 b on the outside and 1 on the inside. That. 24. I don't know the square root of 24, so I got to break it down. That is 2 and 12, and that is 2 and 6, which is 2 and 3. No matter, 2 and 3. There we go. Remember, it's a square root, so it's only 2, so I need 2 pair. That comes out. Everything that doesn't have a pair stays inside, so 3 times 2, or just 6. So this is a 2 on the outside, and a 6 on the inside. Now we got to do the variables. 16 divided by 2, 8. So there's 8 a's on the inside. The remainder is 0, so there's nothing on the inside. B4 divided by 2, B8 divided by 2, sorry, did the math in my head too fast, is 4, so same idea. 4 b's on the inside, outside, outside. And then C is a 1. 1 doesn't divide into 2. It's too small, so it has to stay on the inside. So there we go. Next one, just going to do more of these, right? 18. I don't know the square root of 18. Got to break it down. That's 2 and 9. I do know the square root of 9. That's 3. So the 3 on the outside, 2 gets to stay inside. All the rest divided by the root, the power. So it's 2. So 6 divided by 2 is 3 remainder 0. So 3 a's on the outside, none on the inside. 3 divided by 2 is 1 remainder 1. So there's 1 b on the outside and 1 on the inside. C5. 5 divided by 2 is 2 remainder 1. So there's 2 c's on the outside and then 1 c on the inside. 36, AB4. So square root of 36, I know. 6, done. A is too small, right? It has to be bigger than 2 to come out. So A has to stay inside. Poor A. B4, 4 divided by 2 is 2. So there's 2 b's on the outside. C5, 5 divided by 2 is 2 remainder 1. So 2 c's and then 1 on the inside. Next one, 144 x7y5. So square root of 144 is 12. x7, 7 divided by 2 is 3 remainder 1. So x3, 1 left on the inside. 5 divided by 2 is 2 remainder 1. So y squared and then a y on the inside. Over here, so what happens now? So now you have to multiply them. So what happens here is when you multiply outside by the outside, so outside numbers, so 24. And you multiply the inside numbers times the inside numbers, so 50 y squared z. And then now you still break it down, like 50. You can break down 50. That's 2 times 25. Under square root of 25 is 5. So it's 5 on the outside. Anytime there's 2 numbers on the outside, they're multiplying. That's what's going on. There's a 2 left over on the inside. Y squared, I didn't mean to sound like a question. Right, remember the root is 2, so 2 divided by 2 is just 1. So there's only 1 on the outside. And then z does not enough to come out. So z is on the inside. So I get 120, 120, not 100, 120. I thought that sounded wrong. 120 y square root of 2z. That's the answer there. Next one, same idea. So let's multiply. 6 times 4, 24. Inside, 3 times. I'm going to leave it like this, and I'll show you why in a second. I'm running out of space. I got to erase some of this stuff. So now it's all nice. We have space. And then a is a squared. And then b4. Okay. So we have a 24 on the outside. Now, why did I leave 3 times 24 like this? Well, I have to break it down anyway. So I'm going to break it down right here. 3 times 24, I'll just break down 24 on the side. So that's 2 and 6. And that's 2 and 3. So I have a pair of 2s and a pair of 3s. So they're all coming out. So I have 24, a 2, and a 3 on the outside. And then over here, a squared divided by 2. So you don't say anything. Is a1. Nothing on the left. No remainder. So nothing on the inside. b4 divided by 2 is 2. And same thing, no remainder. So if I just simplify this, 24 times 6, I get 4, 20, 12, 144. 144 AB squared. Same thing with the last one here. This one should be the probably easiest one. 5 times 5 is 25. On the inside, we have a 2. And we have 13 x's. And we have 7 y's. It's an ugly 7. There we go. Right, so we have that. Now I got to break it down. So remember, see root to 2. So 13 divided by 2, 6 remainder 1. So there's 6 x's on the outside and 1 on the inside. The 2's not coming out, so it has to stay up there also. And we just ending with 7. 7 divided by 2 is 3 remainder 1. So 3 y's on the outside, 1 on the inside. So we get that. Next one, I'm going to add these things. So it's a little different. The first step is still the same, though. We got to simplify these because I don't know what square root of 90 is, so I got to break down 90. So 90, that is 2 times 45, and that is 5 times 9. I know square root of 9 is 3. So anytime you have that, it goes on the outside. If there's more than one number on the outside, you just multiply them. So 3 times 3 is on the outside. Same thing on the inside. I have 2 numbers on the inside, 2 and 5. So I get 9 rad 10. That's what's going on there. Wrote that a little big. So this is 9 rad 10. How about this one? 4 rad 20. Let's break down 20. 20 is 2 times 10 and 2 times 5. Pair of 2's. So it comes out. I get an 8 on the outside and a rad 5 on the inside. I don't think that was over on the inside was rad 5. Now, 162. Break it down. 2 and 81, right? 2 times 8 is 162. I know square root of 81, 9. So this is 9 rad 2. And there it is. That's all I could do. They're all different. Can't add anything up. So there it goes. Next one, I think I have some stuff in the next one. 12. 12 is 2 times 6. That's 2 times 3. Pair of 2's that comes out. Remember, there's 2 things on the outside, you multiply. So 18 rad 3. 32. 2 times 16. I know square root of 16 is 4, so that goes outside. So 20 rad 2, because that 2's left over. 72. 2 times 36. Square root of 36 is 6, so that comes on the outside. So be minus 6 rad 2. And in this case, I can actually add the last two. They're the same radical. It's like adding variables. Only if they're exactly the same could you add them. So this guy, I can't touch this guy. It's like I couldn't touch any of these. They all have different radicals. But I could add these two. So it's 18 rad 3 to 3 minus 14 rad 2. That's the answer there. Next, we got to multiply. We'll just do what we normally do. Distribute. So this guy gets multiplied by this guy. Now how do we do that? We multiply the outside times the outside and the inside times the inside. So I'm going to get 28 rad 12, which I'll break down in a second. Then I just got to do this guy times this one. Same idea. Multiply the outside, 21, and the inside, 24. Move on to the next one. Multiply these two. Outside times outside, negative 12, rad 18. And then the last one, negative 9, rad 36. Now you could break down what you could break down. So 12 is 2 times 4. Well, sorry, 2 times 6. Which is 2 times 3. So a pair of 2's. So I get, what is that? 56. Rad 3. 24 is 2 times 12. Which is 2 times 6. A pair of 2's comes out. So I get 42. Rad 6. 6 is a breakdown itself there. 18 is not 2 times 9. Square root of 9 is 3. So times 3. So negative 36. Rad 2. Square root of 36 is just 6, so 6 times 9 is 54. And they're all different. So that is my answer. Right, so that's an annoying one. You gotta multiply them all, and then you gotta reduce them all. That's what we're here to practice. Next one's another one, because I hate you guys apparently. So do the same thing. But what do you notice here? It's a difference of 2 squares. These are exactly the same except for the middle sign. So we can do a shortcut. We should always know different 2 squares. A minus b times a plus b equals a squared minus b squared. So for one, if you had shortcut, you just square the first one minus square the second one. How does the square work? It goes to both of them. So square root of 8 is 64. Radical 5 squared is just 5. Minus, same thing here. Square root of 6 is 36. Rad 3 squared is 3. So I get, what is that? 32 minus 108. So you get 282. 182. And there we go. That's the answer there. And so it's pretty. Next one. So we don't want radicals in the denominator. It's just one of those math things. It's proper notation does not have a radical denominator. So how do you fix it? Well, you can't just multiply by radical, so I won't get rid of it. You gotta multiply by as a conjugate. So rad 3 plus rad 2. Remember, conjugate just change the middle sign. Rad 3 plus rad 2. Whatever you do at the bottom, you gotta do at the top. You do the numerator, you gotta do the denominator. So that's how you rationalize a radical. You multiply both top and bottom by the thing. So on the top, just distribute 6 rad 3 plus 6 rad 2. On the bottom, you can multiply them all out, but again, it's the difference of 2 squares. So it's just the first guy squared minus the second guy squared. So in this case, that'd be 3 minus 2, which is just 1. So I just get this. And no, you cannot do anything. They have different radicals, so you have to leave it like that. Same with the next one. It's again to fraction. I can't have a radical in the denominator, so how do you get rid of it? You do the conjugate, which is you just change the middle sign. So rad 3 minus 6, rad 3 minus 6. On top, you just got to distribute. That kind of annoying. So I get, don't need you anymore. I get 9 rad 3 minus 54, and then you do this one. And you get, that's a radical, so only multiplies by the radical. Negative 2 rad 9 minus 12 rad 3. I'm running out of space. Where's that nicer? So 9 rad 3 minus 54 minus 2 rad 9 minus 12 rad 3. On the bottom, it's the difference of 2 squares, so you just do the first thing squared minus the second thing squared. Okay, then you gotta simplify it. Let's look at this. That can't do anything. That's just 54. This actually could reduce. Rad 9 is 3, so this is just 6. So let's add up like terms. Negative 54 minus 6 is negative 60. I could add this guy with this guy, they're both rad 3's, and I get negative 3 rad 3. On the bottom, these cancel out, so I just get 3 minus 36, which is negative 33. And you get that. And if I want to, I could divide everything by 3, reduce it all and get, divide everything by 3, you get negative 20 rad 3 over negative 11. That's ugly. Okay, let's simplify this. So it's a little practice. Now this is the cube root, so like 16 is not 4, I need 3 at the same time. So let's break it down. 2 and 8, 2 and 4, 2 and 2. Remember, I need 3 of a kind. So these 3 could come out. That makes it 2. This guy's all left hand side. Don't forget the cube root. Like that. How about these guys? Well, divide by 3. y4 divided by 3. That's 1 remainder 1. So there's 1 y on the outside, 1 y on the inside. 12 divided by 3 is actually just 4 remainder 0. So there's just 4 z's on the outside. And there we go. Same to the next one. Like, oh, wait, there's a negative there. Well, it's an odd power, so it does nothing. Just pull it out. And now I need to find the cube root of 54. So 54, let's break it down. That's 2 and 27. And that's 3 and 9. And that's 3 and 3. So cubed, I need 3 the same. So I have a 3 there. And that 2's left all alone again. Don't forget to put the cube root on there. So the rest is divide. 6 divided by 3 is 2 remainder 0. So there's 2 x's on the outside, not on the inside. 11 divided by 3 is 2 remainder, not 3 remainder 2. I could do math. That's a y. 3 remainder 2. So you get that? Those are our answers. Application problems. The diameter of an apple is related to its weight and can be modeled by the formula d equals that. Whereas d is the diameter in inches and w is the weight in ounces. Find the diameter of an apple that weighs 6.4 ounces. So tell me how much it weighs already. So you just gotta sub it in. So let's plug that in. Cube root of 3 times 6.47. Bring out a calculator. I have mine right here. I just got to do that. So math, there's a cube root right there, 4. And 3 times 6.47. There we go. So I get 2.67. That's the diameter in inch. That's the diameter of that. That's the diameter of the apple. That weighs that much. Last two, let's find the area of this rectangle, find the perimeter of this rectangle. So area, remember area formula for that is length times width or base times height. Well, here's my length, here's my width. So 8 plus rad 3 times rad 6. Distribute. I get 8 rad 6 plus rad 18. I probably should break down 18. 18 is 2 times 9. Square root of 9 is 3, so I can pull it out. So this is 8 rad 6 plus 3 rad 2. You can't break down 66. It's 2 and 3. Nothing works any better. How about perimeter? Well, just let me draw it again since I don't have it. So I wrote all over it. So rad 6, 8 plus rad 3. This would also be 8 plus rad 3. This would be also rad 6. So you just add them all up. If you want to use the formula, perimeter equals 2 length plus 2 width. But it's all the same. If I add all that up, I'm going to get, let's just write it. So 2 times rad 6 plus 2 times 8 rad 3 plus rad 3. Over here I can't do anything. Remember, that's outside, that's inside. So 2 rad 6. Distribute. I get 16 plus 2 rad 3. Same idea. I can't do anything there. And that's it. Done. Nothing else I can do. That's the worksheet.